Welcome, inventor aficionados. So what I'd like to show now in this video is how to create basic assemblies. And in our first example, if you wish to follow along, what I've done is just created this rectangular plate, and I've created two of them just so they have different colors, so when we bring it into the assembly there's a bit more contrast between the parts. So the first rule of thumb I would give you as you're learning this stuff initially is when you're creating assemblies, I like to make sure that all of my parts and the assembly file itself is in the same folder, because if you move the different parts to different folders and you end up deleting, or archiving folders and moving things around, the assembly file, when you go to open it the next time, it may not open or function properly. So to create the assembly, come to File, and then click on New, and then click on Assembly. Alright, now there's a couple of different ways of how to bring the parts into the assembly module. The first thing you can do is, or the first approach, is to use the Place icon or button up here. Go find the file and bring it in. And another way you can do it is to right click, hit Place Component, and go to the folder in question with your part. In this case, I want to show you how to open up what I'm calling Plate 1, and then hit Open. You can move the part to pretty much any location on the screen, left click, and when you do that you can see that as I move the mouse around, it will let me create multiple instances of the same part. In this case, I just want the one part here, so I'm going to go ahead and click Escape, and then repeat this procedure for Plate 2. And we'll just left click and then click OK. So I now have an assembly, because as long as I have more than one part, I've created an assembly. So to show you the most basic way to put things together, you want to come up here to the Relationships section and click on Constrain. And when you do that, we now have, under the Assembly tab, we now have 5 different options. And one of the more common ones is the direct mating type. And we see that we have 2 different solutions, and the difference between them goes to how the mate is oriented, if you will. So notice that we're looking at the surface vectors, and you can see in the first one, which is known as mate, that they're sort of opposing one another, pointing at each other, whereas in the flush solution the vectors are pointed in the same direction. So for the sake of argument, let's click on mate, and then let's look at the mate solution. Let's mount this surface to this surface. And I should point out a few things. That what you're seeing right now, after you hear that audible popping noise, this is technically a preview of the mate. The mate is not actually created until you click OK or Apply. So if we were to hit OK, the other thing I'd like to bring your attention to is that the mate itself is tied to your part. So if you ever want to come back and delete the mate, you simply right click and you can delete it, or you can edit the mate as well. Okay, so what did that do? When we mated the parts, what does that mean physically? Well, if I were to orient using my view cube and I were to take left click on and hold and then move my mouse up or down, you can see that I'm moving one of those plates, but the other one, it's still touching it, right? At the same time, I can move everything to the left or to the right on the screen. And again, I'm maintaining the connection between the plates. Let me just show you that in another perspective, that I can move everything around, but these two surfaces are still touching. So the next thing I'd like to show you is, often when you're placing components, you might have to have different features located relative to an axis or a plane or some other surface or feature, and you have a specified distance. So for example, if I come into Constrain and now I'm going to type in, let's say, 0.25 inches. Maybe I want to have a precise gap, if you will, between these two edges. So I can click on this one and this one, and you can see now I have a defined distance of 0.25 inches. And if I ever wanted to sort of verify that, I can come up to Tools, Measure, and I can measure the distance here, and you can see that. Okay. Now, what I'd like to do now is show you an example of the flush mounting. And what we want to do in this particular case is, let's say we want to have this surface and this surface flush with each other. So there's no offset between them. There's no little ledge or gap there, as you can see. So how do I do that? Well, come back into Assemble, come up to Constrain, and make sure Mate is selected. But now select Flush. And now pick this surface. You can select this surface. And now hit OK. And you can see that we have, over here, we have several mates being shown. And now you see what we have, what is known as a flush type arrangement. So hopefully that shows you how to look at manipulating really basic shapes using the mate command. All right, the next one involves using the mate command, but what we want to do is we want to have an angle between two parts. Maybe we don't have an offset distance that's so critical, but we have an angle we want to enforce. So to do that, to show you how to do that, or one example is I basically have these two links. Maybe this is part of a linkage or a frame type assembly, and what I can do is I want to maybe use maybe two things. So the first one I'll show you is maybe an insert command where we'll get the center axes of these holes lined up so everything works as intended. So what I'm going to do is I'm going to pick that one and maybe this one here. Alright, so and then hit Apply, and you can see that we have our links here, and you can see I can move them around if I want with the mouse. But now let's say, what if I want like a 45-degree angle between these two? How do I do that? Okay, or a 90-degree. How do I do that? All right, so if I go to Constrain and now go to Angle, we see three different solutions pop up, and I'm only going to look at this first one, which is known as Directed Angle in this example. So if I pick Directed Angle, and let's say we're going with a 45, or maybe we'll start with 90 degrees. Let's start with 90 degrees, and I pick some lines here to create that constraint. All right, so I'm going to pick maybe this line and this line, and you can see that we have a 90-degree angle shown there. Likewise, I could change this to 45. I could change this to 100 degrees. Pretty much any angle that you want, you can enforce. Okay. All right. So that takes care of that one. And the next one I like to show you is looking at the insert constraint, because often in many practical situations you're dealing with bolted connections or shafts, perhaps going through bearings, that sort of thing. So how do you put those together? What's an example of that? So that's the next one I'd like to review briefly. Okay, so in this example I have this cylindrical extrusion, which as you can see contains some holes, and then I have this bolt, and the objective is to insert the bolt into one of these holes, just to show you how to do that. And there's a few different ways. So if we wanted to consider an approach much like the first one that we looked at earlier, which is using the mating commands, I can come back up to Mate, and notice that when you leave the mouse sort of hovered over a feature, that if you just wait a few seconds, a drop-down menu will pop up, and you see I have different selections. I want to look at this face here, and I need to find a surface on this bolt to do for the mate, and I can probably use this one. Yeah, alright, so that inserted the bolt, and what I can do is I can move the bolt, click this, oops, I lost it because I didn't hit OK. Let me start over again. Alright, so let's come back up to constrain, let's pick that surface again, yep, and then let's come back up to the bolt. Probably I can get away with this and then hit OK. Alright, so if I move the bolt out, we can see that the bolt is in the hole, and the objective might be to have the bolt flush, the head of the bolt flush with this top surface. So to do that, what I can do is hit constrain and then click this bottom surface of the bolt, and then click the top surface. And notice that the orientation is wrong, and to fix that, because right now it's on mate, if I want to flip around the orientation of the mate, I'm going to click on flush, and that gets me kind of what we wanted. Alright, so if I wanted to bring in the bolt once again, just another instance of the bolt. Alright, so now we want to use the insert command. And to do that, I'm going to come up to constrain, and we're going to use the insert, which is the fourth one from the left. Now, what I'm going to do in this particular example is I want to pick this edge that's shown here, because that's going to be that edge will also be flush with the top surface of my cylindrical part here, and then I have to pick the other part, and I'm going to try to pick this center axis, and again, probably if I just flip that around, you see we have basically the same type of result that we had in the first case. Okay. Alright, so in a nutshell, that covers some of the most essential or basic features when it comes to creating different types of assemblies with different types of parts or pieces. So I hope you found this video instructive and helpful. So thank you so much for your time and attention.